Lesson 9.3, Matrix Operations. For matrices, we can add and subtract them. To add and subtract matrices, they have to have the same order or the same dimension, have to be the same size. And then you simply add or subtract the corresponding elements. For example, we'll do 3 plus 0. 1 plus a negative 1. 0 plus a negative 2. 2 plus a negative 3. Negative 4 plus a negative 4. Negative 1 plus a negative 5. So it looks like it's 3, 0, negative 2, negative 1, negative 8, negative 6. For scalar multiplication, a scalar would be not a matrix, it's just a number, so like 2 times the matrix, 3 times the matrix. Anyway, you're just multiplying a matrix with a number, you simply distribute that number through the whole matrix. So it would be 3 times 1, 3 times 2, 3 times 3, 3 times 0, 3 times negative 1, 3 times negative 2. Multiplying two matrices is a little more interesting. To be able to multiply two matrices, the number of columns in the first matrix has to be the same as the number of rows in the second matrix. If you write out the order or the dimensions of the two matrices, this middle number has to be the same. So remember, it's rows by columns, rows by columns. So the columns in the first equals the rows of the second. The outside numbers give you the order or the dimensions of the product. Because of this, order is important, because if I just flip these around, so it's n by p times m by n, I couldn't even multiply these because the middles are not the same. So order is very important. There is no commutative property for matrix multiplication. If you can't multiply it the way it's set up, it can't be multiplied. Let's try multiplying these two matrices. First of all, see if you can. The first one has 2 rows by 3 columns. The second one has 3 rows by 1 column. The middle is the same, and the result will be a 2 by 1. To multiply, pick a row, like the first row here, and a column. So it's always a row in the first, a column in the second. And you multiply the first number, so 2 times 0, plus, multiply the second numbers, negative 1 times negative 2. Plus, and then you multiply the third numbers, 7 times 3, and so on until you run out of numbers. Then you pick a different row and column. Such as the second row and, well, I only have 1 column. It's always a row and a column. Multiply the first, 0 times 0. Plus, multiply the second, 6 times negative 2. Then multiply the third, negative 3 times 3. And then you do more rows with more columns, except for we have already done both rows times the 1 column. So it looks like we have 0 plus 2 plus 21. Second row is 0 plus a negative 12 plus a negative 9 is negative 21. Notice that is 2 rows, 1 column, just like we predicted. Now let's multiply these matrices. First of all, check if you can. The first one has 2 rows, 2 columns. Second one has 2 rows, 3 columns. Yes, the middle is the same, and our answer will be a 2 by 3. So we need to start by picking a row and a column and multiplying those. So it's 2 times -1 plus 0 times -2. It's across the first, down the second. And that's the end of that row and column. Notice that was the first row, first column. So in the place of the first row, first column. Now let's pick a second row. Oh, maybe we can still do first row, but do second column. That's a different combination. So it'd be the first numbers, 2 times 0, plus 0 times 1. And that was the first row, second column, so in the answer it goes in the first row, second column. Then pick another combination. How about we do first row, third column. So that's first row, third column. The answer will go in the first row, third column. So it'll be 2 times 4 plus 0 times 2. And now I've multiplied the first row with all 3 columns. So now let's go with the second row. So second row, first column. Multiply the first, 1 times -1, plus the second's 3 times -2. And then we can do the second row, second column. Be 1 times 0 plus -3, 3 times 1. And then we can do second row, third column. So it'll be 1 times 4 plus 3 times 2. So it looks like we get -2, 0, 8 if we simplify, -7, 3, and 10. There you go.